Are we here because the universe from the very beginning knew we were coming, with all carefully designed laws of nature, so finely tuned to host human life? Or this fine-tuning is just an illusion, and we are here by mere chance and luck?
It is almost like we've been destined to understand the universe and discover mathematical formulas ruling it. Our exceptional planet allows us to thrive physically and intellectually in an otherwise deadly universe.
Hello everyone, thank you for visiting And With All Your Mind, the channel where science and faith shake hands. In the last video, we dove into biblical and scientific account of the beginning of the universe. We stopped on the day 4 when Earth was fully formed with land, oceans, and seeds of life. Before we move on to the emergence of life and humans, we'll hang out a little bit longer around the Big Bang. Are we here because the universe from the very beginning knew we were coming, with all carefully designed laws of nature, so finely tuned to host human life? Or this fine-tuning is just an illusion, and we are here by mere chance and luck? We do know that simple set of rules can lead to unbelievable complexity in nature. So what is it? Are we the universe's pinnacle, or its random fluke? The conviction that the universe has been finely tuned for human life is called Anthropic principle, and it has been debated for a long time. The principle assumes that certain conditions had to be created and finely tuned for life to emerge. The opponents of the Anthropic principle argue that it's very selfish to put yourself in a proverbial center of the universe, and we're really not that special. So, what do they propose? They believe that the universe emerged from a multiverse, possibly endless combinations of universes within the multiverse. So, in one of those universes, the laws of nature, by chance, came to be in a perfect combination to host life and humans in it. Although fun to conceptualize in science fiction movies, a multiverse and parallel universes are not simply observable. They rather overcomplicated absurdity. We scientists use Occam razor to shave off the most unlikely explanations. So which one is most straightforward explanation? A universe engineered by divine intelligence? Or universe plopping into existence from random combinations of conditions? When you think about it, if in every universe within the multiverse, anything theoretically possible can happen, that doesn't negate the existence of God. You can argue that God was experimenting in each of those universes within a multiverse and found perfect conditions to host life and humans in it.
Look around. Carbon life thrives on this planet, in this particular atmosphere, permeated by just the right amount of light, where plants waste oxygen makes it possible for animals to live. Life wheels turn via cycles, from the cellular Krebs cycle, a nightmare of biochemistry students, to seasons, where these fallen leaves become bacteria's food and tree fertilizer in the spring. Earth's surface gravity and temperature have critical values within a few percent to make the atmosphere sustainable and breathable, and allow for the hydrologic cycle to move water from and back to the surface. The ozone layer protects us from deadly UV light, and the Earth's magnetosphere shields humans from solar storms. On top of being so life-friendly, Earth lets us graciously explore the universe by having a transparent atmosphere through which we can peer far in space and time. It is almost like we've been destined to understand the universe and discover mathematical formulas ruling it. Our exceptional planet allows us to thrive physically and intellectually in an otherwise deadly universe. Let's gaze a bit further into our solar system. Our moon has not only taken beating for us by asteroids and meteorites of the past, but also its presence in Earth's orbit is critical to stabilizing Earth's tilt. Without the moon, the Earth's tilt would vary widely. Our planet would wobble in an erratic and extreme manner, wreaking havoc on climate and causing unpredictable ice ages and other cataclysmic events. Also, tides caused by the moon recirculate nutrients and are essential for flourishing marine life. Thorough simulations show that the Earth's unusually gigantic moon is not only unique in our solar system, but also could be an extreme rarity in the whole universe. Our moon emerged from a cataclysmic collision between young Earth and a planetoid. That colliding celestial body had to be precise in size and mass to end up as the moon on the current stable orbit. Based on the astronomical simulations, the vast majority, 92% of Earth-like planets, would end up with a tiny moon or moons without the tilt-stabilizing gravitational companion that our moon gives our planet. Scientists believe that the presence of gas giants such as Jupiter, Saturn, and Neptune on the outskirts of star systems protects the inner planets from asteroids. Those dangerous rocky projectiles are pulled by the gravity of these giant planets and either perish in their depths, become their satellites, or are slingshot out of the solar system. The Earth's orbit is almost perfectly circular, whereas most of planets travel on highly ellipsoidal orbits. Its eccentricity equals 0.02, where 0 is a perfect geometrical circle. The bigger the number, the flatter the ellipsoidal orbit is. This is immensely important for a stable climate. For example, Mercury's eccentricity equals 0.2, and the temperature in perihelion, the point in orbit closest to the Sun, is 90 degrees Celsius higher than in aphelion, the point in orbit farthest from the Sun. If that were Earth, oceans would boil at the closest distance to the Sun, and at farther distance they would freeze, sterilizing all life on the planet. Besides Earth's orbit's almost perfect eccentricity, our planet is also at an ideal distance from the Sun for allowing life to thrive, not too close to the Sun to be scorched like the innermost planets, and not too far to sustain water in a liquid state, unlike the outer planets of the solar system. That just right distance is called the Goldilocks Zone, from an old tale in which Goldilocks wanted her soup to be not too cold or hot. Just a 2% change in our planet's distance from the Sun would not allow life to exist. It may surprise you that almost half of the stars are binary stars, orbiting a shared center of gravity. If Earth orbited around 2 stars, its orbit would be too unstable and unpredictable to support life. Another lucky strike. Let's go into deep space and back in time again. How could the primordial universe with just a soup of hydrogen and helium atoms end up as a paradise for intelligent beings? The laws of nature that originated in the Big Bang allowed carbon atoms, the life-building blocks, to originate in the first generation of stars and to be stable enough not to disintegrate for billions of years. Then, for life to appear, those first-generation stars must have died in violent explosions of supernovae, giving birth to nebulous dust clouds containing carbon. Those dust nebulae would then coalesce under gravitational force and create a second generation of stars, like our Sun, with the planets around them. Carbon, oxygen, magnesium, sulfur, and other atoms must considerably outlive stellar generations to let planets and life emerge and thrive. First, giant stars produce periodic table elements in their inner furnaces of stellar nucleosynthesis, and then small stars burn slowly to sustain planets with life. So how finely tuned are the early universe conditions for these stars to form, especially in such order? Let's take a look at the beginning of the universe. I must warn you that we'll be looking at very, very small and at unreasonably large numbers. When the universe began, there was a brief critical moment in its birth called the Planck Epoch. Epoch is rather an unsuitable word, as it lasted only about 10 to the negative 43 seconds. Yes, 0.4201 second. It's the shortest time current physics can describe, and it's the time required for light to travel a distance of 1 Planck length, another mind-numbing infinitesimal number. It is sufficient to say that Planck's length compared to an atom is like a tree compared to the universe. During that minuscule period, the initial singularity exploded into the early universe, and the expansion rate can be described mathematically as the Hubble Constant, h0. For the universe as we know it to emerge, this value must have been initially equal to 10 to the power of 55, yes, 1 and 55 zeros. And here comes the surprise. If you increase this number by 1 part, the universe expands too fast and no galaxies can form. Without galaxies, there are no star systems, planets, or life. If you decrease this number by 1 part, the universe expands too slowly and soon collapses to where it started, to an uncertain fate without you in it. After the Planck Epoch, from one initial force emerge 4 familiar fundamental forces: gravitational, electromagnetic, and nuclear weak and strong forces. Gravity keeps galaxies, stars, planets, and moons together. Electromagnetic force allows molecules to form. Weak interactions let atoms emerge or decay. And strong forces keep elementary particles in atomic nuclei. How finely tuned must these forces be to act together in such harmony? For example, the ratio of electromagnetic force to gravitational force equals 10 to the power of 39. Increase this number by 1 part, and only small stars can exist. So no efficient nucleosynthesis of life elements can occur. Decrease this number by 1 part, only giant stars emerge, and no second generations of stars come in time. The ratio of the nuclear strong force to the electromagnetic force equals 10 to the power of 16. Change this number by 1 part either way, and no stars can be formed at all. We know that all matter in the universe was created during the Big Bang, and the amount of matter is also vital to our existence. That includes baryonic or normal matter and dark matter, the latter causing the universe to expand, acting as anti-gravity. Today, the ratio of amount of matter to the critical amount, meaning leading to relapse, equals 0.32. However, both regular and dark matter density to critical density at the time of Big Bang must have been finely tuned, such as that changing 1 part in 10 to the power of 15 would lead to a lifeless universe. Decrease it by 1 part, and the universe collapses before there is time for stellar evolution. Increase it by 1 part, and the universe expands so widely that no galaxies could form. Stars, galaxies, and galaxy clusters display a particular order or structure determined by gravity. This structure is expressed as energy needed to break them apart, or their total rest mass energy. That number is 10 to the power of -5, and seems to be imprinted into early universe during the Big Bang. If this number were decreased in one part, the universe would lack any cosmic structures and be inert. Increased the number slightly, and the universe would be dominated by gigantic black holes violently devouring each other in a vast cosmic collisions. I bet I got your head spinning with these numbers, and you're not alone. But the biggest number is still coming up. A lot of scientists and philosophers found such fine-tuning extraordinary and hard to ignore as mere coincidence. Are these imprints of God's engineering in the universe? For me, the idea that the combination of all these parameters came to be by mere chance, it's an absurdity. But for the sake of the argument, let's take a look at the supposed fallacy of the anthropic principle. Philosopher John Leslie uses his firing squad analogy to refute the fine-tuning of the universe. Imagine you are standing in front of the firing squad of 50 soldiers. They all pull the trigger, and they all miss.
What?
Leslie argues that you should not be surprised you survived, as this is the only outcome you could have possibly observed. Conversely, you should not be surprised by the fine-tuned numbers we talked about. This is also the only outcome you could have possibly observed. If those numbers were different, you'd be non-existent. Well, if you ask me, 50 soldiers missing that shot is rather a miracle, or there's something behind it. Perhaps some deliberate intervention to save you from the execution. But let's assume the laws of physics have emerged by chance to support life. What would be the odds to end up with such wonderful creation as our universe? Robert Penrose calculated that the precision of all initial physical conditions of the universe, a God's aim, would have to be accurate to 1 part in 10 to the power of 10 to the power of 123. This number is impossible to display not only on the screen, but also in the universe. There are not enough particles in the universe to represent this number. The current estimation is 3.28 times 10 to the power of 80 particles. If this doesn't convince you about God as the creator of the universe, nothing else probably will. In the next video, we'll pick up where we left off and we'll explore the beginning of life and laws governing the process of evolution. We'll also look into some biblical accounts and search for some interesting inspiration there. Thank you for watching. If you found this content interesting and inspiring, please like, share the video, and subscribe to the channel. I will see you in the next video.